So now let's talk about adding binary numbers. Again, we're going to start by first looking at decimal numbers. The process will be very similar to what we do with decimal numbers. We've all added decimal numbers for quite some time now, and we can see the analog between the two. Okay, so we add some numbers together. Again, slightly random numbers, 3,734 plus 5,168. 4 plus 8 is going to give us 12. Well, that doesn't fit in a single decimal digit, so we take the one that belongs in the ones column, put it in the ones column, the 2, and then we take the value that really belongs in the tens column, the most significant digit, and put it over into the tens column. We carry it over to the tens column. Okay, so we carry this 1 out from this column, the 0 column, and carry it over to the next column, the tens column. Now we add those numbers. 6 plus 3 is 9, plus 1 is 10. Again, doesn't fit in a single digit. Take the least significant digit, the 0, put it in that column, take the most significant digit and carry it out into the next column. Now we get 1 plus 7 plus 1, we get 9. No carry out on that one. 3 plus 5 is 8. Okay, so these are called carries. And it happens when the result doesn't fit in a single digit. Okay, so now let's look at binary numbers. The process is very similar. 1 plus 1. Well, 1 plus 1 is 2. How do we represent 2 in binary? 2 is like that, 1, 0. And so that doesn't fit in a single binary digit or single bit. So we take the least significant bit of the result, put it in the zeros column, and then take the most significant bit and carry it out over to in this case, the 2's column. Now we get 1 for this column. We get 1 plus 1 plus 1. We get 3, which is 1, 1, base 2. So we take our least significant bit, put it in that column, and carry out the most significant bit. Now we get 1 plus 0 plus 0. That's just 1. No carry out on that one. And 1 plus 0, also 1. And so we can do binary addition in a very similar way to what we do with decimal addition. And we can also double check this. You don't have to do this every time, but you can as a double check. We can say, okay, well, did this addition work out? Let's see what this decimal value is. Well, it's a 1 plus a 2 plus an 8. So 1 plus 2 plus 8. $11. And this is 1 plus 2, a 1 in the 1's place, and a 1 in the 2's place. Gives us 1 plus 2 is equal to 3. We added those together. 11 plus 3 should give us 14. Did we get that? Let's see. We have a 1 in the 2's, 4's, and 8's place. So 2 plus 4 plus 8 equals 14. Check. So in fact, the addition did work out. And here it is written and typed out for you for your convenience. Okay, so we can do some more examples in this. Let's add the following 4-bit binary numbers. 1 plus 1 is 2, which is 0. Carry the 1. 1 plus 0 is 1. 0 plus 1 is 1. And 1 plus 0 is also 1. Again, we can check. We can see that top number is 1 plus 8 is 9. We have 1 in the ones place and a 1 in the eights place. 1 plus 8 is 9, and the next number is a 1 plus 4. So 1 in the ones place, 1 in the fours place. We get 5, and we get the value 14. In fact, that is 14, just like we saw before. 1 in the twos place, 1 in the fours place, and 1 in the eights place. 2 plus 4 plus 8 is 14. Check, our addition worked out. Okay, now let's try adding the binary numbers below this. So we have 1, 0, 1, 1 plus 0, 1, 1, 0. 1 plus 0 is going to give us 1. 1 plus 1 is 2. 1 plus 1 is 2, which is 1, 0 in binary. Take that least significant bit, put it there, carry out the most significant bit. Now we get 1 plus 0 plus 1. Again, that is 2. So we take the least significant bit, put it in that column, carry out the most significant bit. And finally, we get 1 plus 1 plus 0, again, 2. So we get a 0, and then we get this carry out. So here is an important point. If you have 4-bit operands, the result is also 4 bits, but somehow we ended up with 5 bits. So the result is just the least significant 4 bits. Here is the result. So 4-bit addition gives a 4-bit result, not a 5-bit result. So 4-bit addition gives a 4-bit result. So we added some numbers that are clearly greater than 1 and got the result of 1. That doesn't make sense. So what happened? Well, this is called overflow. The result doesn't fit in a 4-bit representation. So it overflows the range. The range of a 4-bit number is, again, 0 for a 4-bit binary number. The range is 0, the smallest number, to, well, the largest number is 1111. What value is that? 0 to 15, or more specifically 2 to the 4 minus 1. So it overflowed that range. We can double check that. This top number is a 1 plus 2 plus 8. 1 plus 2 plus 8 is 11. Do write that out, though. Easy to make a mistake there. 1 plus 2 plus 8 is 11. So that top number is 11. The bottom number is 1 in the twos place, 1 in the fours place. We have 2 plus 4 is 6. If we wanted to add those together, we would get the value 17. In fact, too big to fit in a 4-bit number. The largest value we can fit in a 4-bit number is 15. So this is called overflow when the result of the addition is too big to fit in the number of bits. So to remind you here, when we're adding two 4-bit numbers, this is going to give a 4-bit result. 4-bit addition, 4-bit result. Any bits on the left of those 4 bits are ignored. So in general, addition of n-bit numbers gives an n-bit result. So n-bit addition, n-bit operands gives n-bit result. So 32-bit addition gives a 32-bit result. So this is pretty critical. Digital systems operate on a fixed number of bits. So overflow happens when the result is too big to fit in the available number of bits. So our previous example of 11 plus 6 being 17 doesn't fit in 4 bits. Largest number we can represent with 4 bits is 15.